Right then, now these are really exciting. I love these. I'll get my pen going. There you go. Nice yellow. Right, it says here in 20.4, page 300 exactly, we're solving simultaneous equations, but one of them is going to be linear and the other one's going to be quadratic. Well, if you solve a quadratic, you end up with two values, say 2x values, and those 2x values, when plugged into the other equation, will give you two different y values. So you end up with four solutions, 2x's, 2y's. You've got to be careful that when you get two y and 2x solutions, you put the x with the correct y1 and the other correct x with the other correct y1, the corresponding one. Don't just mix it all up and have four answers splashed out anywhere in your exam paper. That's just really naughty. I'll do two from question 1. They say it's grade A, and the one in question 3 is A star. I think it's all A star myself. Right, I've got this equation here. It doesn't look very much. I've got g equals h squared, and I've got g equals 9h minus 14. They say solve them by substitution. Well, okay, g equals that and g equals that. How about I put the h squared right there and get on with it? So here we go. I've got h squared equals 9h minus 14 from the book. Great, I've got an equation with just h in it. Bring everything next door, subtract that. H squared minus 9h equals minus 14. Remember? Bring the minus 14 over and plus it. Not a subtraction, wasn't it? So I've got h squared minus 9h plus 14 equals 0. And I'm quite sure these can factorise because there's no hints that we have to use the formula or anything. So h and h, how do you make 14? 2 7s. 2 7s will make a 9, won't they? Minus 7 and minus 2. Remember? Check it out. H times h, h squared. H times minus 2, minus 2h. I'll write it there. And minus 7 times h, minus 7h. Look, there's your minus 9h's there all together. And minus 7 times minus 2 is plus 14. So let me just get rid of that. That's me showing how you can test yourself. Now, solve. I've got h minus 7 is 0. Therefore, h is 7. One solution. I've got h minus 2 is 0. So h is 2. Second solution. Now we comfortably substitute each of these into the g equals h squared equation. You can put it into the g equals 9h minus 14, but why would you want to do that? This is a lot easier. So let's just take one at a time. So when h equals 7, g equals 7 squared, which equals 49. And we can say when h equals 2, g equals 2 squared, because we're playing with h squared, aren't we? So that equals 4. So what are the solutions? We have h equals 7 and corresponding value for g. I mean x and y, gh doesn't make any difference, but sticks what we've been given. Therefore g, 49, I put 14. Donut. I mean, I know what I meant, I know 7 7s are 49. I even said 49, didn't I? Right, so don't start having a go. Right, and g equals 49, and so that's one solution. If you want to underline it and make sure it stands alone, and I'm going to say h equals 2 and g equals 2 times 2, which is roughly 4. Two solutions, thank you. Well, that's question 1e done. I think I'll do d as well, because these are an awful lot of fun, aren't they? If I start off in blue, you can see what I'm doing, can't you? Right, I've got v equals 4w squared, and I've got v equals 9w minus 5. Now these are a little bit easy, I'm getting bored. Right then, so v equals that and v equals that, so how about I shove 4w squared in there, and we can get an equation with just w in it, nothing else. Bring everything next door. Drops the pen, sorry. Bring everything next door. 4w squared minus 9w plus 5. Remember, minus, bring it over and plus it. Equals 0. It's not. I'm getting a bit scared now. It may be a perfect square, I don't know. You can split this off into 4 w's and a single w, or 2w and 2w. I don't know until I try it out. So let me have a go anyway. How do you make 5? There's only one way to make 5. Is 5 times 1. But look carefully. 4 times 5 will give me 20 w's, so I'm probably biting up the wrong tree. I did do that deliberately, by the way, just to show you how you can think through a scenario that may look a little bit wrong. So I reckon 4 times 1 makes 5. I reckon 5 times w would make 5. 4 times 1 is 4 w's, and 5 times 1w is 5 w's, therefore altogether I'm going to get 9 w's. So I reckon if we go minus and a minus, then we got 4w squared. Yep, 4w times minus 1 is minus 4w's, and minus 5 times w is another 5w's. That's where the minus 9w's come from, so that's good, isn't it? So we don't need that anymore, we know it works. And minus 5 times minus 1 is plus 5. So I'm very confident we got the correct solution. Right, 2 mini parts, that equals 0, so 4w equals 5, so w is going to be 5 over 4, which equals 1.25, 1 1/4. W minus 1 is 0, and therefore w equals 1. 2 solutions for the w. Now let's just do some calculations. Stick it over here. If it stands out in red, it'll be great. Anyway, so when, oh, it's horrible, I don't like it. Go back to yellow. So when w equals 1.25, v equals 4 lots of 1.25 squared. I was just substituting this one because it looks a lot easier than the bottom one, it's just less to do. So pick up your calculator and go 1.25 squared. Remember, BODMAS still lives, BIDMAS still lives rather, so it's 1.25 times 1.25 equals, and then times that by 4, and that gives me 6.25. So v is 6.25. And when w equals 1, I've got v equals 4 lots of 1 squared. Well, 1 times 1 is 1, and 4 1s are 4. There it is. I think I've separated it adequately because I've done that little block when when w equals 1.25, etc. I've given its appropriate v value, and when w equals 1, I've worked out its appropriate v value, corresponding v value. That's okay. Well, that's 2 questions done. I'll probably stop and then do 2 questions from question 2 itself, and take a few more of these word ones, these word solutions. So that's good enough. I'll stop now.